This question is related to topic properties of the material, the solid materials. So brass is an alloy which is made from copper and zinc. A mixture is the ultimate tensile strength, means the maximum stress which the object can bear before it breaks. And the hardness, if it is difficult to indent or scratch on the surface, so we say it is a hard surface. So ultimate tensile strength and the hardness of a brass increases as the zinc content or zinc percentage increases. What is meant by the term strength? So how we define the term strength? Strength is basically like how much force is needed to break the object, that is refers to strength. Or you can also say stress required to break the object. Then what is meant by the term hardness? Hardness is a surface phenomena if it is difficult to indent or scratch. So difficult to stretch or resist to the scratch, we call surfaces hard. Stress and strain graph for a sample of a brass is shown. A typical stress when turning a key in a lock is about 10 megapascal. Using information from the graph suggests why brass is suitable material for a use of a key. So this is a graph is given, stress and strain graph is given for a sample of a brass. The maximum So the maximum stress you can clearly see which the brass can withstand is about 500 megapascal. And when we are typically stressed when turning a key in a lock is only about 10 megapascal. So this is the ultimate tensile stress or UTS. We can say the maximum stress which applied on the object before the object breaks. So the UTS value or the ultimate tensile stress for the brass is very high as compared to when we are turning a key into a lock. We are just applying about 10 megapascal, and it can bear maximum 500 megapascal before it break. So first thing you can mention, brass, it's having a high breaking stress compared to when we apply at 10 megapascal, so the key will not break or deform. And this will keep the shape because after this point, around this point, it starts to show a deformation. You can see here, till this point, there is a very small change because strain refers to change. So till this point, there is a very small change. After that, there's a drastic change like elastic deformation. So if I divide, if the total is 500 from 0 to this, so the center around 250 will be here, or this will be about somewhat 300. So we can say around after 250 or after 300, it start to deform plastically. This region is a plastic deformation. But here we are only applying, because when we are using the key, we are only applying 10 megapascal. So 10 megapascal will be somewhat here. So somewhat here, 10 megapascal, it does not deform. Elastic deformation will not occur. Sorry, plastic deformation does not occur. It will deform, but it's elastically, so the key will regain its shape or key will not deform. Otherwise, what might happen when we are using a brass key, and if it was having a greater, like for a small force, if it deform plastically, then when we are applying a force, the key will start to deform, it will change the shape, and we will not be able to use the key again. So the first thing, it is having a very high tensile, ultimate tensile stress compared to what stress we applied. It's only 10 megapascal. The second thing, that it start to show a plastic deformation after 250 or 300 megapascal, where we are applying only 10 megapascal, so it does not deform plastically. Elastic deformation is there. And the second, another thing you can clearly see that the slope, very steep slope is there. That initial slope, steep means it is stiff. Stiff material means stiffness is very high. Stiff material means that the objects can not deform easily by a small change in the force. So the points which you will mention, number one, very high ultimate tensile stress compared to what stress we are applying. Number two, it will show a plastic deformation after 250 megapascal, but we are only applying 10 megapascal, so it will not deform plastically. And third, you can also mention that it, because a higher, steeper gradient is there or higher slope, so it means it will have a very high Young modulus, so it will be a stiff material. Stiff material cannot deform easily.